Yes, a question is related to the rate of electrophilic substitution reaction over the benzene. And the compounds provided for us to identify the rate of reaction of the benzene with the different substitutions to participate in electrophilic substitution reactions are given by this is benzene substituted with methyl known as methyl benzene. It is also known as what? Toluene. Whereas the second one is reference, that is benzene itself only. This is a regular benzene. This is trifluoromethyl benzene, that is trifluoromethyl benzene. Trifluoromethyl benzene is the name of this particular compound. And this is methoxybenzene known as anisole. This is methoxybenzene. The other name of methoxybenzene is anisole. This is N-N dimethyl toluene, N-N dimethyl aniline, N-N dimethyl aminobenzene known as what? Aniline. N-N dimethyl aniline is the compounds. Whereas out of these of all compounds in whichever benzene system, the more electron density if it is present, then it will become more reactive towards the incoming electrophile. So therefore electrophilic substitution reactions related rate is dependent on the amount of electron density present over the benzene. The more the electron density present over the benzene, more will be the reactivity towards the incoming electrophile. Suppose if we go for the trend related to the electron density present over the benzene ring system. As if I write the structural features, this is methoxy stands for oxygen having 2 lone pairs, nitrogen is having 1 lone pair. As we know, this particular 2 groups, that is methoxy group followed by N dimethyl groups, are plus Me groups. As being these are plus Me groups, I claim it as A, I am claiming it as B, C, D followed by E. As being these two groups are methoxy groups are acting as electron pair donors. As being these are acting as electron pair donors, what happens is electron density present on the benzene ring system increases. As a result, this D and E maintains highest reactivity compared to the others like remaining things. Whereas A is also hyperconjugative group, it is also maintains higher rate. Compare it to benzene followed by what? This is electron withdrawing group, that is fluorine containing trifluoromethyl toluene. Whereas in this set of order of ADE followed by B and C, if you look at our, this is hyperconjugative group. As being it is hyperconjugative, A comes later compared to where? This particular D and E. Whereas in this D and E also if we discuss, in case of D, here methoxy, in case of E, this is nitrogen. Though methoxy is having 2 lone pairs over the oxygen, N dimethyl's nitrogen is having 1 lone pair over the nitrogen. Nitrogen is less electronegative, so therefore electron density is, transfer of electron density is highest in N dimethyl aniline, that is nitrogen associated plus Me group compared to oxygen associated plus Me group. So therefore reactivity is found to be highest with respect to E. Then after chance will come for D. Then after this is A, because A is hyperconjugative group, though this is also plus group, but cleavage of the bonds in hyperconjugation requires more amount of energy. So therefore cleaving becomes difficult compared to the ready-made lone pair of electrons containing system. Hence it takes the next place. Then here chance come for B and C. B is regular benzene reference and it is having trifluoromethyl. Fluorine is electron withdrawing group. If I write the structure, fluorine is minus inductive effect group and it is also more effective. As a result of this trifluoromethyl, otherwise negative hyperconjugation, electron density on the benzene decreases. Here nominal, so therefore B comes later followed by what? The C compound comes at the last. So therefore order of reactivity in electrophilic substitution. This is order of reactivity in electrophilic substitution reactions of substituted benzenes appears as here E greater than D. Somewhat I will write at the top. So therefore reactivity appears as E greater than D, D greater than A greater than B, and the last it comes for the what? C compound. Hence the order of reactivity appears as like this. So the answers related to the order of reactivity in electrophilic substitution reaction. Compound E stands for N-dimethyl benzene is highest. Then it proceeds by D compound, that is methoxybenzene. Then after this is methyl benzene followed by regular benzene followed by trifluoromethyl benzene. Here plus Me effect, here also plus Me effect is present, here minus Me effect is present. This is regular system, and here what, and plus hyperconjugation is present. This is minus hyperconjugation is present. As being it is minus hyperconjugative group, electron density on the benzene decreases. As it decreases, its reactivity in electrophilic substitution reaction also decreases. The next question is related to the paper chromatography. In paper chromatography, which of the following is correct? And from the extraction of the given options, it reveals us. In paper chromatography, what happens is, whatever paper we are taking, that cellulose paper is having holes, pores. In that pores, water is present. That water as a polar medium appears as a stationary phase. Hence, the correct option related to the paper chromatography is water present in the pores of the paper forms as or works as stationary phase. That solid makes a solid skeleton. On that solid skeleton, the stationary phase is offered from the polar medium. That is what water is acting as a stationary phase, whereas our mobile liquid is acting as what mobile phase.